afternoon, everybody. Thank you for attending the North Wales Branch Technical Afternoon. Our guest speaker today is from SC Davis and Sons. I'm ready to subject dredging.
Good afternoon, everybody. Thank you very much for inviting me to talk. I'm Paul Davis. I'm fourth generation of SC Davis and Son Limited from Worcestershire, and we're primarily crushing and screening and plant hire. So the origins of the business, the yard, which is 25 acres, was bought in 1930 off the University of Oxford as a research site. It had been since 1870, and it was where they experimented with bricks and clay. There was a brick kiln on the site, and also a sand quarry. The farm was bought in 1930 as a derelict quarry, and it was backfilled in 1939 by the War Agricultural Committee. And my great-grandfather, which was SC, Sidney Ernest, he started chick hatching and poultry business. That grew through the 30s and 40s, Second World War, and in the early 50s, we started in lorries, hay and straw haulage, and moved on to demolition. Demolition contractors all through the 70s and early 80s, when my father sort of took the business in a different direction in the plant hire. So the plant side of things then really took off, and we started crushing in the late 80s, early 90s, and we travelled all around the country as crushing contractors. By the end of the 90s, things were sort of slowing up a little bit on the crushing front, and we started looking for something else. And in the mid-2000s, we hit on the idea of washing and washing quarry waste in many different forms. And the dredging was born on the back of that. The family involvement is very much a family business. Both of my sisters, my mother and father, my father's wife, and my wife are heavily involved in the business, and both of my sisters' husbands as well. So it is a real family business. We employ 55 people based in Worcestershire, as I say, and we operate in quarries and sites throughout the country, anywhere from Scotland down to the Isle of Wight, Isle of Man included. We even got washing plant working at the moment on Anglesey. So we travel absolutely anywhere, really. In 2020, we started on a bit of a different path with extending our facilities, and we built a custom-built workshop for the design and building of our mobile washing equipment. The facility is now up and running, and it's something that we're very proud of as a family, enabling us to come up and design lots of different projects to lots of different solutions. We had two 12.5-ton synchronized lift overhead cranes. So we've got 25-ton lifting capacity with all our own in-house fabrication facilities. The plant that's on the screen at the moment is going to Tor Works for a dust washing project, and that's currently being built, is due to be finished next week. Our core business, as I've touched on, has always been crushing and screening and aggregate processing. These couple of pictures here in Cleal Quarry, where we're processing blasted rock into type 1 and into single sizes. We run 6 crushers, jaws and cones, and 14 track screeners. So, mineral processing is sort of what we've always done. The washing plants, as I said, were born sort of out of the working in quarries, seeing the heaps of waste and problems, scalpings, dust, anything else that sort of might come about. And we designed our washing systems to be very mobile, very quick to set up, with a very small footprint. We don't need concrete slabs to set them up on. We arrive on site. Normally the crane work's done within a day, and we're up and running within sort of 2 days. That's the core of our business. As I said, scalpings, dust, surface dressing materials. We've washed glass, coal, pretty much anything you fancy. This slide here, this is a plant we built last year down in Heathrow. This is working in Stanwell Moor for Brett Aggregates. This is a soil washing facility where we're washing material with a silt content of 35%. So, very high silt loadings are something that we deal well with. Dowlow Quarry, where we were washing dust. We did 75,000 tonne of a 6 mil down dust for them up there. As I said, our plants are modular, and most of them are built by ourselves. The picture on the right there, that's actually going in a rail yard in Kingmore in Carlisle. That's a coarse material washer and sand system, all in one unit. We take an all-in feed, anything 40 mil down, and produce 3 grades of aggregate and a sand off that out of recycled rail ballast. We then treat the water through a centrifuge and a settling system, and reuse the water within the system. So washing 1,000, 1,200 tonnes a day, and we're using no more than about 6 cubic metres of water an hour to process that material. We have a large fleet of self-drive and operated plant hire as well. So all of this equipment that we're sort of discussing is building up to the dredging project, because we'd got the infrastructure to start with, we'd got the roads into the quarry, and we knew the people. So it was the next logical step really to do something like it. We run all our own transport and our own cranes. Most of what we do, we set up ourselves. We run a large fleet of Arctics, heavy haulage capacity up to 70 tonnes, step frame and low loaders. So we're not reliant on other people's haulage. We do sort of everything in-house ourselves. So how did the dredging come about then? So about 6 years ago, we were approached by Brett Aggregates in Pinewood near Ivor to clear a silt lagoon out. They'd had a long reach excavator in, which, due to the nature of where it was, could only reach 6 to 8 metres from the bank, because the silt lagoon was very deep, which then gave them a short-circuiting problem in the lagoon. We've got a large collection of vintage and classic plants, so we rebuilt a 22 RB excavator, a heavy-duty machine, and we were able to dredge the lagoon for them, very effectively. And it's sort of, our wash plant was feeding into the lagoon, so it all fed on that, we were filling the lagoon of silt. So if we could offer the quarry a solution to move in the silt, then all well and good. So we dredged that 2 or 3 times for them, and it worked very well. Because we then started advertising a bit of dredging, more people got interested. There was a bit of a campaign on social media, and we were approached by a paper mill from Winchcombe in Gloucestershire about clearing a tailings pond for the paper mill. So the bottom right-hand picture is a dredging scoop that we built that was based on a design from 1880, John Fowler patent design, that was originally designed to be pulled with a ploughing engine, a steam ploughing engine, which you can see in the picture there. And we used the exact designs that were from Reading University, and we built a dredging scoop. So basically, it's a box with 2 skids and a tailboard in the back. When the one engine pulls one way, the tail door slams shut, and it digs just like a bucket, holds 5.5 cubic metres. And when the returning engine pulls back, the tail drawer opens and the scoop slides back through. So this was a job we did for the paper mill. We used a D8 tractor that you can see in the bottom left-hand picture. It was 145 metres across the lagoon. That D8 tractor was built in 1934. The air conditioning is fantastic, as long as the wind's blowing the right way. And we pulled the scoop backwards and forwards between the D8 and then a Unipower winch tractor on the other side of the bank. And we pulled it up to the front end, and then had one of our excavators loading a 40-tonne truck and tipping the slurry into a pre-made lagoon. And it all worked very, very well. And we could see from that then that, the dredging, it had really got legs. There was definitely a market for it. Nothing more sort of happened really then for a couple of years, other wash plants and various things, until I had a call from Adam from Subalco. And in typical Adam style, he came up with a list of requirements that were not only impossible, but they were slightly insane. He wanted a dredge that had got no man on. It couldn't have any diesel fuel or hydraulic oil. No fuels, oils or greases at all on the dredge. It had got to be completely remote control. It had got to dig 5 metres deep. It had got to pump the liquid 700 metres away with a static head of 40 metres. And I got quite excited and thought it was a brilliant idea. And as a family, as I've said about the family business, we have a meeting on a Sunday night where I sort of come to the family and said, look, I've had this idea. Adam wants us to build a dredge. There's work there for it. I think we can do it. And when everybody had finished laughing, the resounding the answer was absolutely not. You must be off your rocker, we're not getting involved with floating things on water. So went back to Adam and said, the family said no. And Adam didn't give up, fair play to him. He then rung Dad and said, you need to let him build this. So we set about it. I did all the designs myself. I've never used any computer-aided software or anything else. As you can see from the middle line, it's all chalk work and a bit of guesswork as well, and sitting and scratching, and we designed it. So you can see there the 2 pontoons. We spoke to a firm in Italy called Dragflow and got them to design a pump for me to do exactly what we wanted, which was a high flow, low head pump. And the build commenced. We had the pontoons made by a firm in the Black Country who built them to exactly what we wanted. And we set off from there. Now, as I sort of went on building this thing, it got to a point where it was sort of very nearly constructed. And everybody kept saying to me, well, do you think it'll float like? And it's so demoralizing, really, when everybody who's working for you, including the family, sort of wonder if what you're doing is actually going to work. So I lost the head with it one afternoon, and a friend of mine owns a marina about 10 miles down the road. So I said, right, we'll see if it'll float. Let's go and put it in. So took it on the wagon and took the crane and dropped it in, and it worked perfect. But the night before, stood in the workshop, everybody was looking around it, sort of asking whether they thought it would float or not. And they got me to draw a line on the side and sign my name above it to see where the water had come to. And I must admit, I was 7 mil out. So it didn't do too bad, really. Didn't do too bad. Now, and from that successful test, then we went on with the winches and the electrics and got the thing finished. And this is it going in for the first time in North Devon into the clay works there. And it was good. It performed, as well as could have been accepted, really. One of the other problems that we sort of faced was how to move the material away from the dredge. The pump will pump up to a 60 mil solid, and obviously with this job we needed to pump it 700 meters, and we got 40 meters of static from the water line up into the lagoon that was made on the tip. So we used a booster pump system, an automatically controlled booster pump system. And then the hose line, obviously going back to our thing about the mobile washing plant and being quick and easy to set up, we went for a lay flat type hose, which came from a firm in Germany that build slurry systems for the agricultural business. So it's designed for pumping sand. It's relatively lightweight, and we can carry 1,000 meters with us on the reeler, which you'll see some pictures of in a minute. The pipe is laid out with a 21-ton excavator. And on good going, we can sort of put 500 meters of pipe out in less than half an hour. So there's no manual handling, there's no joints and lifting pipe work. It's lightweight. It's an easy system. And then at the end, you just reel it back up with a hydraulic reeler on the excavator, and off you go to the next job. Weight was an issue because we couldn't get the crane too close to the edge of the lagoon. So we kept the weight to around about 6 tons. And so the rest of it's history, really. The dredge is controlled by a cabin on shore, and the operator sits in the air-conditioned cabin and watches the dredge working. You can see on that picture there the 2 winch ropes coming off the front. There's 2 ropes on the front and 1 rope on the back, and you sort of steer yourself across the lagoon in an arc fashion. So the things that we got wrong when we started, we had the pump sticking straight out the front of the ladder, because the idea was we'd be digging at around about 5 meters deep. So by the time that the head went down, you were at an angle where the pump was very nearly vertical. And then we had the stirrer mounted above the top of the pump with the idea that it would agitate the liquid around it, which worked fine on the Devon clay. But when we moved up into Cheshire, into a lagoon that got a high sand content, it just wouldn't do it. You were trying to pull the pump sideways into a solid bank all the time. So we made the pump so we could change the angle, we could vary the angle of the pump, and we also added a second stirrer and mounted it on the side. And we tried that for a few days, but the diameter of the stirrer blade, the bottom right-hand picture, in the sand, the stirrer just kept tripping out. It's all variably controlled, but it hadn't got the digging force. So we modified the blades in the workshop and put the bucket teeth on, so it will excavate the sand. And a little later on, there's a video which you'll see, it was digging sand that was half a metre out of the water down to about 5 metres in the lagoon there up in Cheshire. And we were pumping that around 850 metres to its final destination. So, the stirrers and the angle of the pump, we got really wrong at the start, but we learned from that and moved forward. With the pump being at the wrong angle, it was drawing clean water in from the top and not drawing the silt in from the bottom, where now we have a job to keep it thin enough, if you like. The density is incredibly high, all the time, really. Some of the lagoons we go to have got very little water in them to start with. And you can see the centre picture there. We got dropped literally onto a sandbank and had to excavate our way into the silt. And as you can see, it's mostly sand, fine sand in that lagoon there. So we were digging the sand and pumping it out. We created a hole, and then the boat sort of slithered into its own hole, and then we set off dredging. The bottom left-hand picture, that's working on ultra-fine material. That's a silt that's been settled after an ultra-fines plant. There was no freeboard or water at all. That was like being dropped straight into, custard, effectively, really. And the pump handles that, no problems at all. We can pump sort of up to 30% solid with the machine. Obviously, then dealing with that liquid is the next challenge. So we've developed various ways of dealing with the silt. Most places want the operational lagoon emptied. In the top right-hand picture there, that's a lagoon in the bottom of a China clay pit down in Cornwall, a Devon-Cornwall border. And we were actually pumping that material back into the process plant. So there was no wastage on that job. Everything we pumped out went straight back into the plant, and then the kaolin was recovered from it that way. With the washing systems that we have, we can pump the material that we're excavating straight into a mobile sand plant and a dewatering plant, and give you a product, directly off, if you like. So a fine sand, or in some cases a coarse sand, straight off the sand plant. Then we can treat the water, put the silt through a centrifuge, return the clean water back to the pond, and give you a handleable cake out of the centrifuge as well. So if you need total lagoon cleaning, then that's an option as well. The biggest benefit, I think, to this system, one is the safety aspect. You're not working an excavator right near the edge of the bank. Two, you're not spilling slop and silt all over the quarry floor when you're trying to excavate out of a hole and move it with a dump truck. It's a much more efficient process. 2 men, it doesn't need 2 men. 1 man is operating the machine. The other man, really, because you're working by water, is acting as a lone person supervisor, if you like. And it's relatively low impact. Diesel usage, we're somewhere around about 220 litres a day for the generator that powers it all. And that includes all the booster set and everything. We have the excavator on site to act as a moving anchor to help us position ropes and various things around the lagoon. And it's a simple system, really, with very little mess. As we talked about the pipe work, we had a heavy duty reeler made for the pipe work. The reeler can be mounted either on the front of the tractor or on an excavator. We tend to use the excavator mount for putting the pipe work out, because you can position the reeler much more effectively. And then the booster set that we built there, which is a 6.4 EAH Warman, which will do 75 metres head at round about 180 cube an hour. Most places we work, we're around about 40 metres head, and we can do sort of 250, 260 cube an hour through that unit then. The ancillary equipment, this is dealing with the dirty water again, if you like. Sand plant in the left-hand picture, we can pipe directly into the sand plant and recover the sand. The middle 2 pictures are a dribble bar, which will fit either on an agricultural tractor or on an excavator. So up in the North Devon Clay Works, we actually capped an old tip. We put a layer all over the tip using the excavator and the dribble bar. You can see it coming out of the nozzles there. It's quite thick. It's a good consistency, which we just track the machine about. Then the umbilical pipe work then sort of follows you up and down the tip, and you just put a layer all over the top of the tip. So handling the sludge is a possibility. It isn't an issue. We run mobile flocculation systems as well, so we can pump flocculant into the dredging line and settle the solids quickly in a small space, and then return the water back to us. That's another add-on that we can add into the system. We'll do all our own testing. We're agents for Chimera flocculant, so we can supply the right powder for the job and sort of move forward like that, really. There's a video now. I'll shut up for a minute and let you enjoy it. This was taken up in Cheshire for Sabelco, operating in one of their sand sites. you could see that the middle of the lagoon had been left. The outside had been dug with an excavator some months previous, but it's as far as he could reach, and that was about a 45-ton long reach excavator, but couldn't get to the middle of the lagoon. And what then basically happened was he dug all around the outside. The lagoon then lost its settling capability, and you effectively dug a ditch all the way around the outside. So where the infeed was going, it just raced around the outside straight to the outfall. So you didn't have the settling anymore. So that's obviously why the dredger then worked well, excavating the middle out to give the lagoon its depth and its capability back. This is just a very short video of the density of the sludge coming out of the pipe. That was recorded at 1.32 density. So it's pretty thick stuff, really. If you've got any questions, then I'll be happy to answer them for you.
Thanks for that, Paul. That was very interesting. Showed great innovation around the problem. Very impressed.
What I was thinking, Paul, you've sort of bolted on lots of different applications depending on the mineral and so on. But would you change anything for the original dredge? Because it looked as though it stayed the same.
The actual vessel itself, I wouldn't change a lot about it, really. I'll talk a little bit about the future in a moment, but no, the actual vessel itself works very well. The only thing we've made the major modifications to really is the ladder design in the middle and the way that the pump is mounted. I think the future really for us is to try and make a machine which is self-moving now, so we don't need the winch ropes. Getting anchor points can be an issue in some quarries. So I think the next thing really is to try and make the vessel move itself, walk effectively to where it needs to be. Then we don't need the crane to be able to launch it. And there'd be, a lot more areas we could actually get to if we could make the thing self-moving.
Thank you.
Hiya, Paul.
Hello, Rob.
It was really just to let people know that the machine really does what it says it does, but we got caught out with a catchment area. We thought we created three lagoons to catch the slurry, and it wasn't long before it filled up. And the point I'm making is you'd be surprised how quick this machine does move the product. The only other thing I'd like to say is that it is quite robust and diversified, because if you remember the first lagoon that we operated on, Paul, the material was probably -63, -90 micron.
Yes.
And the first cutter worked very well, but when we moved into Lagoon 1, it struggled. And you put those, were they tips from a bucket to cut through?
Yeah, the agitators on. Yeah, that's right.
So the diversity of the plant is very, very good.
Yeah, well, thank you, Rob. Yeah, thank you.
And then Siobhan Hall, hopefully you're still on the call if you want to unmute yourself and chip in.
Hi, I wondered, it looks like most of those examples were of silt lagoons. I wondered if you've used it in a sand and gravel or a sand quarry scenario where we're actually dredging the material to go into the plant to be processed. I wondered if you've used it in that aspect yet, and therefore what would the largest particle size be that your dredger can handle?
Well, the pump is capable of handling a 60 mil solid. I don't think we'd want to be pumping too much of that, to be honest. I think sort of 10, 12 mil really, if you were pumping it consistently, would be about where you want to be. Down in Cornwood, when we were working on the clay down in Cornwall, we were pumping sort of 20, 30 mil particles and a lot of sand all the time, because it was what had washed down the haul roads and washed off the faces into the bottom of the quarry. And it handled that, no problem at all. We've never tried digging virgin sand and gravel, although I believe that I think in the next few weeks there is a project plan that we are going to actually be digging virgin material, or certainly sand anyway. So it'll be interesting to see how it performs in that, really.
Thank you.
First off, great to see something completely designed and built from scratch. Really good to still see that happening. Did you have any issues with sort of CE marking or patents or anything along those lines?
No, we researched the patents quite carefully to make sure that we weren't infringing anybody else's design or anything else. But because we're not selling the machine, it isn't, it doesn't become too much of an issue. It's our own machine. In terms of CE marking, we had the design approved and we've had engineering drawings done. All the calculations have been founded. So we've got an engineering technical file that that backs it up effectively. And any modifications or changes that we make, we then have to, amend the files and make sure that we keep the paper trail up to date. So that side of things has been a relatively straightforward procedure, really.
Interesting. Thank you.
Phil Gerrish here. I wonder, when you were, I'm in Cornwall actually, and I was just looking at the clay works. Did you have many problems with wear and tear from the quartz and everything, particularly in the pipeline?
No, we were worried about that because the frequency that the quarry were wearing pipework and fittings and various bits and pieces out, we were concerned about the wear factor that we got down there. We did, I think it was about 14 weeks production down there, and pumped around about 450,000 cubic meters through the system in the time we were there. And the measurements on the impeller, on the pumps, on the booster set, and on all the pipe work, we suffered sort of no noticeable change whatsoever. We sized everything with a velocity of around 2.8 to 3.4 meters per second. So at that, you can keep your wear rate something sensible. Yeah. So no, it hasn't been. It's been a concern, but as yet we haven't had too much of an issue with that.
And in your lagoons, do you get much vegetation and stuff that could sort of too soft to pump and maybe block it all up?
Yeah. No, that is an issue that we have experienced with vegetation, and the system, I've got to admit, isn't fantastic on it. Roots and things, sort of smallish roots to do with reeds and bits and pieces like that, we don't have too much trouble. The main bottleneck for that is the 6-4 Warman. So if we're going on any sort of heavy vegetation, we change the impeller in the pump to a 2-vane open impeller, so we can get the efficiency that way. But you do lose production then. There's no doubt about it. The impeller on the actual dredging pump itself, we don't seem to have too many problems with. It seems to cope with that fairly well. But the vanes on the booster set is where we have the issue. We modified that slightly afterwards, so it makes cleaning much easier. It's on quick clips. We put a local isolator on the pump, lock it off, take the in-feed off, and you're straight into it there. Unblocking it then isn't too difficult, really.
Thank you very much.
You mentioned something about the future, Paul?
Yeah, so the future, really, I've sort of started designing the next one now, as I say, to try and make it move itself. The biggest issue with trying to make it move itself is still to keep this design brief of no hydraulic oil or no oil. The easiest way is to do it with oil, but we are looking down the sort of electric routes. We're looking sort of back to the past, really. As I said, we've got quite a passion for vintage and classic machinery, and if you look to the past, there's very often solutions there. There's Ford came up with a design in the 20s which was like 2 big corkscrews, and the machine effectively walked on its own corkscrews. And there's ideas like that we're trying to look at the moment, to try and come up with some sort of innovation, because the last thing you want is to be 200 meters out in the middle of the lagoon and it throws a track off. The other problem, of course, is not having an operator sat on it. You haven't got that feeling when it's all going wrong and it's tipping a bit sideways. When you've got an operator, you can feel it. But when you're sat on the shore pulling some levers, the thing will be upside down. So, we've got the next one, really, we've got to make it simple, but it needs to be the next step on, really. It really does, yeah.
Sounds interesting.
It's probably worth saying, Paul, the only downside to you having a self-walking dredge is you won't be able to turn up at site with your James Bond-esque line launcher, which was the highlight of the first visit.
It's funny, when I was putting the presentation together, I've got a video of the first time we did it. And my partner has helped me put the presentation together. She said there is no way you can put that in to a group of quarry managers and expect them to take you seriously. Basically, the device that Adam is referring to it takes a 2.2 rifle blank. I imported it from America, and it's called a line launcher. And what we do is we have a lightweight line attached to a aluminium projectile. It's all risk assessed, by the way. We stand on the boat and fire this projectile up to 200 meters across the quarry. And then that enables us then to pull the winch lines out. And it is unbelievably effective. And you get most of the quarry stop and watch you doing it, because it is really interesting when it goes off. It's a hell of a bang. But I think Adam went out and bought himself one.
I did, yes, I did. With the excuse of dog training. Dog training was the excuse.
Yes, yeah.
Well, thank you so much, Paul, for your time. And it was very interesting and informative. And I think, hats off to you, fair play for showing the innovation. It's excellent.
No problem. Thank you very much for inviting me. Thank you.
Thank you for your time.
Yeah, thank you.
Thank you all for joining, and stay safe.